All right, this is a re-recording of the class lecture for 7.1 part 1. The reason for it is because I forgot to record. So this is going to be 7.1. Make sure my pin color works. This is part 1. Ah, come on. So those of you that are at home and needed a part 1, I forgot to record the class lecture for it. So we're going to go kind of quickly through this here. But at the same time, hopefully get the information for it and get you prepared for 1.7 part 2. So first things first is the title. So 1.7, this is called transformations of the parent function. So 1.6, go back to 1.6, we learned about all the different parent functions. We'll call them basic functions, or sometimes called parent functions, sometimes called mama and papa functions. So basically you have the square function, you have the square root function, you have the cubic function, the cube root function, the linear function. And again, go back, I know I'm just spitting these out of my head here, but go back to 1.6 to review them, just to make sure you got them. We have the linear function, the identity function, the constant function, the rational function, or the reciprocal function. And then we tacked on a few more called the absolute value function and the greatest integer functions. Those are all part of that piece. So go back 1.6 notes, make sure you got all of them. So for this one, what we're gonna do is we're gonna actually do Desmos. Desmos is a graphing, online graphing calculator, technically. And I use it quite a bit. For myself, as well as to graph things here. So here's what we're gonna do. We're gonna just try a few things here. We're gonna put in x squared. So you should all know what x squared looks like. It looks like this. It's a parabola that goes down. In fact, I'm gonna slide it in just a little bit more. So there it is. Okay, so now the question is this, and we're going to get to the rules here in just a bit here, but let's kind of play with this designation first here. I got the red function here. I'm going to put in the same exact thing here, except what I'm going to do is I'm going to move it 3 units. And so notice what happens from the red graph to the blue graph. We have ourselves, this blue graph is 3 units above the red graph. And so notice also, trivia question. Trivia question is, are the graphs getting closer and closer to each other? So that's the first thing that we should kind of think about. Answer is no, they are not. These graphs are always, always, always going to be 3 units apart from each other. So notice right here, it's 3 units. Notice if we get to 1 right here, this red dot here and this green dot, guess how many units they are away from each other? 1, 2, 3. All right, let's go a little further. We've got a dot right there. Is that right? 2, 4. And then we go to the x2, 7. What do you know? So even though visually they look like they're going towards each other, they are always 3 units away. And so we say this. We say that the blue graph is shifted up 3 units from the red graph. There's a vertical shift. The blue graph has a vertical shift of 3 units above the red graph, or 3 units up. So let's go with it. So what happens if I put in plus 5? What do you think is going to happen? Plus 5. I change it to a 5. Sure enough, we just go higher, right? So now the question is, how about if I go minus? What's going to happen? Yep, you have a vertical shift that's going to go 4 units, or if I do minus 4, 4 units down. So this little number at the end, each time, if it's plus, it goes up. If it's minus, it goes down. Interesting. Okay, so there it is. There's a vertical shift. So let me actually bounce back between, yeah, let's go to here. So I'm going to go like this. I'm going to say what we just learned is don't just number 1 and number 2. So if you want to write this down, pause the video if you need to here. These are called vertical and horizontal shifts. If C is a positive number, the horizontal shifts are going to happen like this. So you have a vertical shift of C units upward. So if you're adding C, so just copy down 1 and 2 for now, and then we'll copy down 3 and 4 as soon as we're done. So vertical shifts upward and vertical shift downward. Notice what happens. It happens when the C value is outside the function. So adding 3, adding 5 made the value or the function go up. Subtracting 4 made the graph go down. Okay. Pause the video there. I'm going to go back now to Desmos. And I'm going to go with a different kind of flavor here. What happens if I were to minus a number here? Or actually, let's do plus first. I'm going to add 4 to this function. Let's see what's going to happen. Notice the 4 now is on the inside of this function. Whoa, that's interesting. There's my red graph, original graph. I added 4 to the graph. And what happened is actually it slid the graph to the left. So exact opposite of what I think would have happened, right? If I'm adding 4, you'd think it'd actually go to the right. But because of the way functions work, in fact, the reason why it works is, the question is, what do you need to get x? What does x have to be in order to go back to 0? And the answer is -4, that's why. It works, okay. So if I say negative or +7, it's just gonna go 7 units to the left. So we have ourselves a horizontal shift to the left 7 units. Okay, so then the question is, what happens if I subtract 3? What do you think is going to happen? Guess first. Do the guessing. Subtract 3 is going to same exact shape, but moves it to the right 3 units. And again, we're going to start graphing these in just a bit here, but just for us to get used to it. All right, so there's the other 2. So let's go back to our slides now, and let's copy down numbers 3 and 4. So here's what we got for 3 and 4. So now we've got these horizontal shifts. So horizontal shift of C units, it goes to the right. If it's inside the function, you're subtracting. So exact opposite what we would think it would happen. Horizontal shifts to the left if you're adding the C inside the function. So notice the C is on the inside of the function for the horizontal, outside for the vertical. Okay. Again, pause the video if you need to in order to copy that down. Okay, I am going to get out of here, and I'm going to jump back to my Desmos screen here. So here's what again, don't need to follow me on this one, right? I'm just going to doing here. So let's change the function around. Let's see how this is going to work. Instead of being a square function, I'm going to take a square root function. Now let me erase this guy for now. Okay, square root function. This is the way it does. This is from 1.6. I know it does that because the square root of 0 is 0. The square root of 1 is 1. The square root of 4 is 2. Exact 4, but there it is. There it is, 4, 2. Okay, so let's do this here. So I'm going to write another square root function, and this time you guess what's going to happen here. I'm going to add 3. What's going to happen here? Adding 3 to this function. So the 0, 0 now becomes 0, 3. This 1, 1 now becomes 1, 4. So notice the y value has changed. 4, 2. How about 4, 5? So the y value is 3 units up each time. Okay. Minus 2. Again, predict where the graph's going to be. There it is. 0, 0 now became 0, -2. And notice that the curve is exactly the same though, right? Notice the curve just goes out like that each time. Okay, so there's our shift. Moving on to the inside, if I were to add 4, what's going to happen? Add 4 to my graph. predict. A goes to the left 4 units. So 0, 0 now goes this way. It goes to the left each time. 1, 1. That goes 1, 2, 3, 4 to the left. Here now. Now it's a negative 3, 1. Let's see, 4, 2. Went 1, 2, 3, 4 back. Now that one's actually 0, 2. So notice it's affecting the x values. Okay, so let me change it around. What happens if I were to subtract 3? Subtract 3 from the function. Now it's over here. Okay, so that's the vertical shifts, horizontal shifts around. So let's do some problems. All right, so let's do just quickly with this here. Can you do this here? This will be example for exercise number 1. So here's my original function, f of x is x squared. Can you graph for me g of x, which will be x minus 3 squared plus 4. Notice I'm adding 2 things together here. I'm adding a horizontal shift and a vertical shift at the same time. All right, so original graph f of x, we should graph that one. F of x, this one you should know from chapter 1.6, right? It goes through 0, 0, 1, 1, 2, 4. Also negative 1, 1, also negative 2, 4. So it comes down like this. And comes back up like that. Okay, so now let's graph the g function. So we're going to graph the exact same function, except what are our changes here? So I'm going to say it like this. I'm going to say we have a vertical shift 4 up, and we have a horizontal shift 3, oh, right or left? To the right, because it's a minus here. So there it is. So we're going to graph the same exact function, incorporating these things in it. Let me change my pin color and change it to black here. So this little 0, 0 now goes, we go to the right usually first. 1, 2, 3, 1, 2, 3, 4. So here's my dot. I went 3 to the right. I went 4 up. That's called a vertex. So we're going to do the same thing to each of these dots. So this one, 1, 2, 3, 1, 2, 3, 4. Again, I'm going to erase my lines. I just want to show you the lines here just so you know where we're coming from. And then this red dot is going to be 1, 2, 3, 1, 2, 3. Oh, we're missing it. I think I go just 1 up. That's fine. I'm going to go 1 up to here. I go a little bit tiny out of my graph and it'll still be okay. Okay. Ta-da, this one right here. Now it's going to be 1, 2, 3, 1, 2, 3, 4 is right here. And then you kind of guess almost where the next one's going to be. Can you guys guess that it's going to be about right here? So there it is. So what I've done is I've made an x squared function, a new one, and I've translated it 3 to the right and 4 up. Okay, that's a cool one. Let you try here another one here. If you got it, try this one. So exercise 2, we're going to use a square root function. And what we want to do is do this. We're going to go that and that. All right, so original function, square root function. And if you don't know how to graph that one, you have to go back to 1.6 and see with the square root function. What does that look like? The square root function starts at 0, 0, goes through 1, 1, goes through 4, 2, goes through 9, 3, but that's kind of already outside of our bounds for the graph here. So it goes like that. There's my original function. So what's happening here and here? So I have a horizontal shift of 4 units to the left, because it's positive. I have a vertical shift of 3 units down. So can you do that for each one of those 3 points that we just graphed? Can you shift each one of those points 4 to the left and 3 down? And we have ourselves our next graph. So let me change pen color again. So here it is, 1, 2, 3, 4, 1, 2, 3, it goes right down here. 1, 2, 3, 4, 1, 2, 3 goes down here. And 1, 2, 3, oh, outside the graph again a little bit here. 1, 2, 3 goes down here. And here's my graph this time. Okay, good. So this is called transformation. So we are taking a function, we can easily translate it or transform it into a different function just by moving dots around. Okay, now let's take a look at some other ones here. Back to Desmos. All right, I'm gonna change it up now. Let's see, I'm gonna go back to, oh, get rid of that one too here. Let's see, X squared again. It's a green function this time. That's okay, green function. All right, this time what I'm gonna do, I am going to put a negative in front of my function. And notice what happens, the difference between the green graph, original one, and the blue graph. So it goes down. And so the green graph just kind of, we call it a reflection. It's almost like if you swing the green graph across the x-axis, you'll produce the purple graph right over here. So this one calls for a reflection about the x-axis. So let's try maybe another one function. I think this can do absolute value function. You guys remember those? Absolute value function. Maybe it makes everything absolute value, right? So it makes everything positive. So this is going to be 1, 1, 2, 2, 3, 3. This guy is a negative 1, 1, negative 2, 2, negative 3, 3 right here. So if I stick a negative in front of the absolute value, you can notice it goes down. So I've got this little correspondence here. So we say this is a reflection about the x-axis. Another one would be a good one here, square root. Yeah. Square root function. Okay, and I stick a negative in front of the square root. And notice I have myself the purple graph. Again, reflection right about this here. So you reflected this would be 1, 1. You reflected about the x-axis. Doesn't want to get me to 1, 1. There it is. Yep. Come on. There it is. And you reflected back over here, which corresponds to negative 1, 1. Okay. So reflection about the x-axis, I'll write these down in just a bit here. But now the question becomes this. What happens if I were to reflect this? Let's get rid of this here. Put a negative inside this function. Whoa, hold on. If the negative is inside the function, what happens is it actually reflects it about the y-axis. So instead of the green line going out to the right, now we have a purple line going out to the left. How interesting. Okay, so let's write this down. Back to our graph here. So reflections in the coordinate axes right here. So reflections, our coordinates of y is equal to fx are represented like this. So if you have a reflection about the x-axis, the reflection happens when you have a negative totally outside of the function. There's a negative outside of the function, which kind of makes sense because all it is, it makes all the y values negative. That's all that happens. If you have a reflection about the x-axis, what's happening is that you have a negative that's multiplying the x on the inside this time. Okay, so then let's go with our, we did this one, we did this one. Let's go to a next one now. Next one, do this. Can you graph for me exercise 3, f of x is equal to, let's do square root. Square root g of x is going to be the negative of the square root. All yours. I know you just saw it on the graph, but I want you guys to try it here. So the original graph of square root of x is 0, 0, 1, 1, 4, 2, and so on. And the graph looks like that. Okay, because of this, we have a reflection. And reflection about the x-axis, because the negative is on the outside of our function. So let me change pin color here. So all we're going to do, the 0, 0 still stays, because it stays, there's no change there. But the 1, 1 goes across the x-axis 2 units. The 4, 2 goes across the x-axis 2 units. And so here it is. There's my, come on. There it is. It's supposed to be. All right. Let's go another one here. Exercise number 4. So let's do the square root function again. So can you graph this one again for me? You're going to get really used to these. And I'm going to put the negative inside the function this time. So again, try to graph it. We already graphed some Desmos. Make sure that we graph it here. And pause the video if I'm going a little too fast here as well. So the square root function, again, it starts at 0, 0, goes up to 1, 1, goes up to 4, 2, and so on. There's my designation. What happens when the negative is inside the function? We do have a reflection. But now it's about the y-axis. Okay, so y-axis means now everything corresponds this way. So 0, 0 still stays because it's right out the origin. 1, 1 goes to negative 1, 1. And 4, 2 now goes to a negative 2, 4. Oh, sorry. Way right there, negative 4, 2. Notice that the x values are the ones that change. Okay, so there it is. There's my graph going the other way. Okay, and the last one here before time runs out. Let's go back to this one right here. So this is number 5. So f of x is equal to the square root of x, g of x. I'm going to combine both of these guys together here. So now a reflection and a shifting. Can you guys do those? Give you guys a little bit of time. I'll pause it. Try it yourself first. I'll come back and do it. So yes, you are supposed to graph the original function first, f of x. You graph that one, and then you graph the corresponding g of x. Okay, here's it's going to get very used to the square root function here. Square root function gives you this. Change pin color. So this guy, we've got to figure out what these guys are. This is a reflection about the x-axis. That's right, it's outside the function. And this is a horizontal shift 2 units where? Left or right? It's +2, so it goes to the left. Okay, so let's see if we can make that happen. We need a reflection, and we need to move it to the left 2 units. Okay. So if we move it, let's see, if we reflect 0, 0, still at 0, 0. And we move it back 2 units, it's gonna be right there. This one reflected and then move back 2 units, puts us right there. I'm gonna erase my little markers of how I got there. This one is gonna be reflected 2 units now. So it goes 1, 2, 1, 2. It's gonna be here first. That's my reflection. And then it goes back 2 units right there. So this is a way we graph functions. We graph functions by knowing the parent function and then just shifting, reflecting, and next time we will learn stretching and compressions. So, all right, all for today.